Absolute value inequalities. By the end of the lesson, you should be able to answer the question, what is the relationship between absolute value inequalities and compound inequalities? To understand this relationship, let's consider the inequality, the absolute value of x is less than 3. Please remember that absolute value means the distance from 0. So if we consider what values are less than 3 units from 0, well, that would be as whole numbers 1 and 2, and all those decimals in between, and it would get really close to 3, like 2.99. So I put an open circle on 3, and I shade from 0 to that open circle. But also, in the other direction, there are values that are less than 3 units away, and that would be -1, -2, and it gets really close to -3, so again I put an open circle on -3. This graph should look like a compound inequality to you. These are the values that are greater than -3 and at the same time less than 3. Remember that this can also be written with the x in the middle, saying -3 is less than x, which is less than 3. Now let's consider the other symbol. If I have the absolute value of x is greater than 3, this is saying what values are more than 3 units away from 0. Well, on the right, it wouldn't include 3, but really close to 3, like 3.1, and everything beyond. But also, on the other side of 0, what values are more than 3 units away from 0? That's everything infinitely to the left. This graph hopefully looks like a disjunction to you, or an or. This says x is less than 3 or x is greater than 3. So from these two cases, I want you to see that the one on the left, when it's less than or less than or equal to, it's going to be an and. A mnemonic trick to help you remember this would be, you read those symbols as less than. Well, if you just say less than, emphasizing a D on the end, I know that's spelled incorrectly, but that will help you remember it. Whereas if it's greater, or greater than or equal to, if we say greater, spelling it again incorrectly, but that will help you remember that this will turn into an or. So, in general, to solve absolute value inequalities, what you're going to do is isolate the absolute value expression. Once you do that, you're going to split it into a compound inequality. Remember your mnemonic device, less than or greater. Then you're going to solve both of those inequalities and graph your solution. Let's make sense of this with an example. So, first step is isolate the absolute value expression. It is isolated, so I'm going to split this using the word and, because it is less than or equal to. One of my inequalities is exactly as I see it. The other one, we do two things. We have to reverse the direction of the inequality symbol and make it -2. Now, I prefer to write this with the x plus 1 in the middle, less than or equal to 2, and at the same time greater than or equal to -2. Either is correct. I'm going to solve it using the second option. So my goal is to get x alone in the middle. I will subtract 1 from both inequalities, giving me -3 is less than or equal to x, which is less than or equal to +1. This is easy to graph. -3, -2, -1, 0, and 1 go on my number line. I will use a closed circle on both, and I need to shade the values in between. All of these will satisfy my original inequality. If I took any value from the shaded region and plugged it back into the original, it must satisfy it. Let's do another example. This one is greater than 6. So this tells me that I need to split into 2 using the word or. One of them, again, is exactly as I see it, dropping my symbols. The other one, I always do two things. I switch the direction of my inequality symbol and make it the opposite value. Now I need to solve both inequalities. This gives me 2x is greater than 10, divide by 2, and I get x is greater than 5. Over here, again, adding 4, 2x is less than -2, divide each side by 2, and I get x is less than -1. Here is my solution using the word or, and I'm going to graph my solution set. negative 1, 0, 1, 2, 3, 4, and 5. I will put an open circle on negative 1, and I shade the values to the left. My graph's a little sloppy here. Open circle on 5, and I shade the values to the right. This graph is, again, a disjunction. Now, number 3 is the first one, where the absolute value expression is not isolated. So I'm going to begin by isolating it by dividing each side by this coefficient, the negative 2. This cancels, which leaves me with the absolute value of 3x minus 1. Negative 2 divided by negative 2 is positive 1, and because I divided by a negative, I must remember to reverse the direction of the inequality symbol. Now that it's isolated, I split into 2. I read the symbol, that's a greater than sign, so it's an or. One of them, exactly as I see it. 3x minus 1 is greater than 1, or 3x minus 1, do two things. Switch the direction of your symbol and make it negative. Now let's solve. So we are going to add 1 to both sides, giving me 3x is less than 0. Over here, 3x is greater than 2. I'm going to divide both by 3. I get x is less than 0, and x is greater than 2/3, with the word or in the middle. Now, occasionally kids struggle the moment they have fractions to graph on a number line. It's really not bad, especially because my numbers are little here. If I have 0, 1, 2, if I put little marks for my thirds, that would be 1/3, 2/3. So it would be an open circle on 0, and I'm shading to the left for x is less than 0, and then open circle on 2/3, and I shade the values to the right. Remember that this represents all the solutions that satisfy the original inequality. Okay. Again, in this one, it's a slightly more complicated, but our goal is isolate the absolute value expression. So I subtract 4, because I must undo addition or subtraction first. You do not get rid of the absolute value signs. Get rid of the 2 by dividing each side by 2. So I have the absolute value of x minus 12 is less than or equal to 3. Now that it is isolated, I split it into 2. This is less than or equal to, so this is an and. One of them is exactly as we see it. The other one, I do two things. X minus 12 is greater than or equal to negative 3. Now again, I prefer my nested notation with the x minus 12 in the middle. It's less than or equal to 3, and at the same time bigger than or equal to negative 3. I'm going to solve it from this compound inequality. So I add 12 to get x alone in the middle, which gives me 9 is less than or equal to x, which is less than or equal to 15. Let me fix that. 15. Now I graph this. I just counted by 3s on my number line, 9, 12, 15, 18. This time it will be a closed circle on 15, closed circle on 9, and we have to shade where our two graphs intersect, which is in between. Okay. You should now recognize that when it is a less than or equal to, this will be an and. Greater or greater than or equal to, this will be a compound inequality that is an or. All right.